Okay. Alright, so first thing I want to look at is where it says right here, rate of change. Remember, rate of change is just how our points are going from one to the other. That's what it's saying, or how it's moving across the graph. This says a ratio. I want you to underline that word. A ratio is just a fancy way that we say fraction. A ratio is just a fancy word for a fraction. That describes how much one quantity changes with respect to change to another quantity. So, I don't know if you've ever heard it called like the change in y over the change in x. That's what it's talking about, okay? Is how much something changes based off the other. How much the dependent variable changes on your independent variable, okay? The rate of change can be determined from equations. So what you just did on the quiz. It can be done from tables or graphs. Equations, tables, or graphs. Okay, we call those representations. So you can have one equation and it be, or one function and it be a table, a graph, and a equation. So they may represent the same thing just in different forms. So when you hear me say multiple representations, that's what I'm talking about. Okay. Slope can be described as rate of change. We just talked about that. Linear functions have a constant rate of change. Bless you. Okay. Some of y'all remember doing CROC, like constant rate of change. I don't know if you remember doing that. You may have, depending on what teacher you had in 8th grade. But linear functions, the reason they make a straight line on the graph is because they have a constant rate of change. It's always from one point to the other going to do the same exact thing. So like for example, if your slope is 3 over 2, every point is going to go up 3 over 2. And then let's do it again. So up 3 over 2 is going to be constant. So they increase and decrease at the same rate over a period of time. Remember that a horizontal line has a rate of change of 0. Okay, that means the slope is 0. And a vertical line has an undefined slope. That doesn't mean it has no slope, it just means that it's undefined. Does anybody remember the little acronym that you learned that helps you remember what is it? It's HOIBUX. So we're going to write that. Okay? It's horizontal, has a 0 slope, and the equation for it is y equals something. That's the HOI. What's up? It's in your notes. It says rate of change of linear functions. You didn't get that whole packet? Look one more time and I'll come back over there, okay? Alright, so HOI, and then it's V for vertical, U means undefined, and then X means that the equation is X equals 2. It should be behind the one we did yesterday. The one that says linear equations, it should be the next one. Keep going. It's that one, right there. You just passed it. Go back one more. It's the front of that page. Did it say rate of change? Okay. Alright, so that's a little acronym. If you can't ever remember, if you can memorize that, you're set. Okay, that's how you can remember the O and the 0 and the undefined. Okay. The slope formula, we should all remember that. You use it so many times, it's probably drilled in your brain. It's m is equal to, does anybody remember what goes on the top of the fraction? It's y something. y2 minus y1 over x2 minus x1. That's true for it doesn't have to be like constant. So when we start doing average rate of change, when we get to like quadratic functions and exponential functions, it's the same idea, okay? It's still y2 minus y1. We're picking 2 points and we're trying to find the rate of change between them. Okay, so what we're going to do is we're going to look at these examples. We're going to look at the different kinds that you see. If you notice, like this one's an equation, this one's points, and this one's a table. We're going to do this side. So we're going to do example 2 first, okay? Let's look at example 2. In an equation, where do you think you look to find the rate of change? The slope, okay, and where's the slope going to be? Like, what is it always going to be next to? The x, okay, so on this one, this tells me the slope, so all I have to do for an equation is just look at it. If it's in slope-intercept form. On that one, the rate of change is negative 12. Okay, which means you would go down 12 and then right 1. Alright, on number 4, it says determine the rate of change between the points negative 7, 2, and negative 7, 8, okay? What I always do, because I used to be so bad at mixing them up, okay, I always label them first. So, negative 7, is that an X or a Y? That's an X, that's with my X1, and if that's X1, what does 2 have to be? Y1, okay? And then this negative 7 is going to be my X2, and then the 8 is going to be my Y2. Okay? That is the easiest way to not mess it up. Okay? It takes 1 second to label them, okay? So now when I set it up, who thinks they remember how to set it like the whole top? Oh, you think you remember? How would you set up the top?
8 minus negative 7.
Oh, wait, pause. What's the Y1? 8 minus... 2. Okay. So 8 minus 2 on the top. Okay, and on the bottom, I would do my X2, which is negative 7. And when you do minus a negative, what does it turn into? A positive. So if you just want to write plus, because to show that that was negative and now it's changed, I don't care. If you want to write minus the negative and put it in parentheses, that's totally up to you, okay? Whatever makes the most sense in your head, as long as you remember that minus a negative turns into a positive. Alright, so then we put this in our calculator. We do not have to simplify the top and then the bottom. We can type it all in at one time. Ready? I'm going to do 8 minus 2 on the top, then negative 7 plus 7. When this pops up, what is that telling me my slope is? Undefined, okay? If my slope was 0, it would say 0. So on this one, what our answer would be, if you were to simplify it, it would be 6 over 0, so you get like a divide by 0 error. But this would be an undefined slope, okay, but we're talking about undefined. And if you want to note on your thing, if this was like on a graph, it'd be like a vertical line, like negative 7, 2, negative 7, 2 would be like right there, negative 7, 8 would be like up there. It's just a vertical line, and the points are on top of each other, okay? So that's kind of what that would look like. Alright, then example 5, it says calculate the rate of change over any interval, okay? Sometimes when you read a problem like this, it'll say like find the rate of change between x equals 1 and x equals 4. Like it'll tell you specifically which points to use, but this one we don't really have to. If it's just telling me to find the rate of change from the table, we can pick any 2 points. They can be consecutive, which means they're right next to each other, or they could not be, okay? Because when they simplify, it should all be the same rate of change. So I'm going to pick this one, the 1, negative 4, that's going to be my x1. This will be my y1. Okay, and then I'm going to do the 5, 28. So then I'll do x2 and y2. If you want to pick different points for me just to practice, that's fine. Okay, so I'm going to pick those 2 to do the example. So m is equal to, draw a little fraction. What goes first on the top? y2, so 28. Minus negative 4. So what could I write to simplify that? Plus 4. And then x2 minus x1. Someone tell me what the whole bottom is going to look like. Minus 1. Is the one I did. Okay? Minus 1. Alright, again, I am a big pro for putting it on my calculator at the same time, so that I'm not having to simplify a bunch of things and have more room for error. So 28 plus 4 over 5 minus 1. Okay? So my slope on this one is 8. Alright, any questions so far? Should be a little jog of the memory, okay? I want you to do the odds, so 1, 3, and 4. Oh wait, how did that happen? This is supposed to be 5. Okay? And this is supposed to be 6. I'm not really sure what happened there, okay? I want you to do the odds, so this side, do that and then put your pencil down. So do exactly what we did on this side, but for these. Do those on your own and then check with the person beside you. Okay, Will, example 1, what was the slope? On number 1?
Yes.
What'd you put?
Nothing.
Okay, Camden, number 1.
8.
8. It's just in front of the X.
Oh.
Okay. Number 3, you should have labeled, or if you, that was something. If you should have labeled if you wanted to kind of make it a little bit easier for yourself, but, Blakely, can you tell me how you set up your fraction? What'd you put on the top?
2 plus 3.
2 plus 3, again, that's the same thing as 2 minus the negative 3. If that doesn't make any sense to you, please ask questions about it. And then, what'd you put on the bottom, Blakely?
Negative 9 minus 6.
Negative 9 minus 6, okay? Why did that one not turn into a positive? Anybody?
It's a 6 and a negative.
Because it's minus a positive 6, so the sign doesn't change, okay? And then, Ryan, what'd you get on this one?
I got negative 1/3.
Negative 1/3. Okay, again, type that whole thing into your calculator, and that gives you negative 1/3. It simplifies it for you, okay? Remember, when we do slope, it's going to want it in like the simplest form. So if you do it for some reason just in your head and you get a fraction, make sure that you still check it in your calculator, because sometimes it can reduce, and we don't want to get the wrong answer because we didn't check it, okay? And then number 4, Heather, did you do work for this one? Okay, which 2 points did you pick?
I put 3 and 10 for
Okay.
this one.
X1 and Y1.
And then 3 and negative 1 for those 2.
Okay, good. So she picked 2 that are right beside each other. Anybody pick different ones? Okay, cool. Just watch and see, and let's see if it's the same thing, okay? So how did you set up the top of your fraction?
Negative 1 minus 10
Negative 1 minus 10.
over X, 3 minus 2.
Good, 3 minus 2. Alright, and then everybody, what did you get when you did that? Negative 11, okay? You should get the same thing whether you did those points or not, okay? Remember, there's a constant rate of change, so it's the same no matter what points you choose. I did the first 2 and got the same thing. Okay? Any questions on that? Alright, flip it over. Alright, from a graph, okay? Then I would think graphs are where people mess up the most, okay? You have to read it the right way to be able to do it from a graph. And you also have to pick the right points. So when we're trying to read it from a graph, and this is true for any kind of function, you have to look for perfect points, okay? Can anybody explain to me what a perfect point is, like what I mean by that? Okay.
Whenever the line crosses like the...
Right, like it just needs to be like on a cross. It doesn't need to be like, let's see, like I wouldn't want to pick this random spot on the line, okay? I know it's kind of hard to see on my screen, but on yours you should be able to see what I'm talking about. It needs to be on a cross. So what I did is I picked the line